All right, back by popular demand, here to do some more physics problems. Problem 6, had a few callers reach out and say, how about this one, Mr. H? And I said, no problem. Now, this one is probably the hardest one on the thing. This one a 9. I haven't really done, to be honest, I haven't done 9 yet this year, so from what I recall, these two were two of the more challenging ones. And I have worked this one out, and there's several pieces involved with this. So make sure you have a full sheet of paper, and we'll see if we can get it all done in this one. And I'm probably going to be scrolling clear down here and utilizing all of this, and so we'll see how neat I can be. All right, so first off, I'm going to draw on this diagram and draw maybe red, so I'll just do blue. Okay, so we have some forces on this. The free body diagram, we got Fg, and we can calculate Fg, right? Fg is mass times gravity, acceleration due to gravity, 9.81 meters per second. And when we fill in mass, our mass is 1.33 grams, and 1.33 grams is equal to 0.00133. It's 3 to the left, decimal place 3 to the left to get it to kilograms. You must have kilograms to get units of newtons. So there we go. 0.00133 times 9.81, and for me, that gets me, oh my goodness, where did I put that one on here? Did I not even put that down? Problems of not actually, there it is. Writing some things down here. 0.00133 times 9.81, 0.01347, and it's newtons. Okay, now what other things do we have here? Well, this electric field is pulling it this way, right, up to this corner. But instead of writing it like this, it breaks the electric field into an X component and a Y component, which that really does help us out. I'll make one of these green. So the X component will be to the right. See, this arrow is up and to the right. So we have here, we'll call this EX, the electric field force. How about FEX? FEX, that sounds better. And the force due to the force due to an electric field on with a charged particle is EQ. So we'll call this EQ. Okay, we'll call it EX times Q. And then we have an up piece. Maybe I'll call have a different color. How about purple? And on this one, we'll call it FEY, and that's EY times E subscript Y times Q. So it's just the product of those two, just like this, two items, two things multiplied together. So you have three forces, and the last force is this tension in the string, okay, and it's here. We'll call it FT. So there's our forces, 1, 2, 3, 4 singular forces in this diagram. Okay, well, let's do this. Let's break FT apart. We're going to break FT. What's a good color for us? Maybe this one. So let's do this. This is, instead of FT in this direction, we'll call this FTX. And we have an upward piece, which is FTY. So we split this FT into those two, or we are going to. So we have this angle. So let me redraw that. So this. So this is FT, and this angle is 38.4, given to us in the problem. And this is FTY. This is FTX. And so what we can do is we can write that's FT. FTX is the sine opposite over hypotenuse. So that it is the sine, let me do this a different way. The sine of 38.4 is equal to F opposite FTX over FT. Okay, so then we multiply FT over here, and we get solve for FTX. And instead of the sine of 38, I'm going to put it as a decimal, 38.4, sine of 38.4. So this is 0.6211 times FT. All I did was multiply the FT over here and make a decimal equivalent of this, or approximation, not equivalent if I want to be technically correct. Now if I do it for the other one, FTY, it's cosine, right? So it's the cosine adjacent over hypotenuse. You do the same thing, and you get FTY, so is equal to FT, and the cosine in this case is 78.3, point, what am I doing, 0.737837. So point, that's a decimal point, sorry. Okay. Close parentheses there. All right, so we have that much. We also know we have this here, right? So I'm gonna, and this is EY and EX, we know those. So I'm gonna redraw this free body diagram. It's getting rather cluttered, and I'm only gonna put this force, the purple, the green, the blue, and instead of the black, I'm putting these two maroon ones. So we'll draw the Q ball here, Q ball, Q charged ball. Playing billiards now. And we have, we have FEY, and that is this FEY, which is this thing here, times Q. We don't know what Q is, which is actually what we're trying to find in part 1, so this is 4.89 times 10 to the 5th Q. Separate that. We know green is FEX, and that is equal to this charge here, the XE field, EQ, remember the formula is force due to an electric field is the electric field times the Q in there. So this is 3.99 times 10 to the 5th times Q. And I checked that the units play nice. Newtons per coulomb will solve for Q in coulomb, so that's to the 5th power though, right away. Sorry about that. And then we have blue, which we already have. And blue is 0.013047 newtons. And that'll be units of newtons, and that'll be units of newtons. Now we got the two maroon pieces. So this piece here is we're gonna use this guy right here. So that is FT times 0.6211, and then this is FTX, by the way, and this is FT. Oh no, this is FT. No, it's FT, guys. Sorry, FT. We substituted in. The whole thing is FTX. See, FT times this. The whole purpose was to get one less variable. Yeah, FT. Sorry, and this one is FT times 0.7837 FT. So there we go. There's our 5 singular up and down, left and right forces. Now this thing is in static equilibrium, so the x's equal each other and the y's equal each other. So that we're going to write those two expressions, set up the system of equations, and solve for q. Okay, so there we go. Here we go. So the sum of the forces in the x direction, equilibrium. So we know the sum of the forces in the x direction is 0. So this one, Ft times 0.6211 equals, section that off, and that equals 3.99 times 10 to the fifth times q. There's two variables in there. Okay, so we cannot solve that yet. We have to do in the y direction now. 0.7837 Ft plus this one, which is 4.89 times 10 to the fifth q. So the sum of those two has to equal the bottom one, which is 0.013047. So we did, this is the sum of the forces in the y direction are equal to each other. The top up equals the down, and the left equals the right here, okay? So we have two equations, two unknowns. So solve it however you wish. I'm going to solve by manipulating this one first and simplifying it a bit. So I'm going to solve, which way did I solve for in this case? I solved for, I think I solved over here, yes. So I solved for q, and I divided by this over here, and when I divided by that over here, I got 1.5567 times 10 to the negative 6th Ft. Then I package this and put it in over here. So it is 0.7837 Ft plus 4.89 times 10 to the fifth times, what was q? This beast over here, 1.5567 times 10 to the negative 6 Ft equals 0.013047. Now we can multiply those two and combine like terms, so it's all an Ft term. And when I do that, I get 1.5449 Ft equals. So now we divide these two and we get F force, tension force of 0.8445 newtons. So that's the tension force. And so if you look here, that's that answer right there. So see that? It's right, where's my thing? Here, there. I got that right. And then we need Q, right? So now we got to back substitute into here. Four, 4, 5. I basically took this and plugged it in there. Sorry about that. It looks a little bad. Equals Q. And when you multiply those two, I get a Q of 1.3147 times 10 to the minus 8th. And what unit should be on this? What do you think, guys? You should be shouting it out. Coulombs. C. So this is our other answer right here. So if you look up here, there it is right here. I would suggest not rounding too much until the end because that can drift you off. But there are those two pieces, so that's quite a bit. Let me know if you need extra help on this. I'll do problem 9 as well, but this was problem 6. So, thank you.